As of now, we spoke about one type of product between two vectors that gives us a scalar quantity, and this is known as dot product. So one very common example in physics of a dot product is work. Work is a scalar quantity that only has magnitude and no direction, and it is obtained by taking the product of two vectors, the force vector and displacement vector. Now, a second type of product between two vectors exists, and this is known as cross product or vector product. Now, one very common example in physics of a cross product is torque. Recall that torque is a vector that is obtained by taking the product of two different vectors, the lever arm vector given by R and the force vector given by uppercase F. So generally speaking, let's suppose we have two vectors, vectors A and vectors B. So we can take the cross product of those two vectors and we get a third vector, let's say vector C. To find the magnitude of vector C, we can use the following equation. We take the product of the magnitudes of vector A and vector B and we multiply that product by the sine of the angle theta between vectors A and vectors B. So this equation gives us the magnitude of vector C. What about direction? C is a vector, so that means it not only has magnitude given by this equation, but it also has direction. Now, to find direction, we have to apply something called the right-hand rule. So we take our right hand and we orient our fingers in the direction of vector A, and then we curl the fingers in the direction of vector B. We extend the thumb and the thumb points in the direction of vector C. Now note the following important points. The direction of vector C is always perpendicular to vector A and perpendicular to vector B. Now, suppose we have the following two vectors A and vectors B. Now, these two vectors are three-dimensional vectors. So that means each one of these vectors has a y component, an x component, as well as a z component. So let's suppose that we want to find the cross product of vector A and vector B in the same exact notation. To find our vector C in this notation, we have to use the following method. So this method is the cross product method, in which we essentially draw a matrix. We have two rows and three columns. Each column represents all of our components. So for example, the first row represents all our three components, the x, the y, and the z component, and the second row represents the x, y, and z component of the second vector. So we essentially do the following procedure. We take this quantity and multiply it by this quantity and then subtract the product of these two quantities. So YA multiplied by ZB minus ZA multiplied by YB. Now this quantity gives us the quantity of the x component, so the I hat. Now, what about the y component? To find the y component, we multiply ZA times XB and subtract XA minus ZB as shown, and that gives us the y component quantity. What about the z component? Well, to find the z component, we multiply XA YB and subtract YA multiplied by XB, and that gives us the z component, which represents the k hat. So we have I hat, j hat, and k hat, and this vector is our c vector. And the direction of the c vector is perpendicular to both a and b and is found by the right-hand rule. So if vector A points out of the board and vector B points along the board, then to find our C vector, we take the hand, we point the fingers in the same direction as A, we curl in direction as B, so going this way, extend the thumb, and the thumb points upward. And this vector C is perpendicular to both B and A, as shown by these two 90-degree angles. So let's suppose we have the following example. So the lever arm vector r is given by the following equation: 5i hat plus 6j hat plus 1k hat. We want to calculate the torque if the force is F equals 10i hat newtons. So notice our value for the j hat and k hat is 0. To find the vector notation for torque, we have to use this form, this procedure. So we have this vector r and this vector f, where the j and k hat have a value of 0 each. So we follow the same exact procedure and we get the following result: 10j hat minus 60k hat. Notice our value for I hat is 0. So this is our torque vector in vector notation. What about the magnitude of this vector? To find the magnitude, we simply take the sum of the squares of these two component quantities and take the square root of that sum. So the square root of 10 squared plus 60 squared gives us approximately 60.8 newtons times meter. So this is the magnitude of the torque vector, and we obtained it using this procedure.